Hello! In our last video, we were looking at indefinite integration and some of the examples for the very basic stuff when we literally looking at like the arbitrary constant of c and how that actually works. So now we're going to look at specific techniques and ideas involved with indefinite integration. And you saw a list there. Perhaps we have reverse chain rule, we have trigonometry, exponential, and natural logarithm as well. So here's the first example. This is just an introduction again to how you may rearrange and simplify a function first of all, and then you will start to do the integration process. So put in our dx there, of course. And again, I'm kind of doing this in a way that you've seen the first video, so I'm not doing every baby little step. So just take care here, x to the power of 4 minus x to the power of 3 over 2. So using exponents, remember when they're dividing, you'll subtract them. So now we're integrating. So instead of 5 over 2, it's plus 1. So 7 over 2, 1 over 7 over 2 to the x to 7 over 2 for the first term there. And for the second term, you're doing the same thing. So just be careful. It can look a little bit awkward. And when you're rearranging, try and get used to the little trick steps. So like, 1 over 7 over 2 is flip it, 2 over 7. And you can see there with x to the 7 over 2, if you think about it, that's 3 whole and 1 extra half. So I've also rearranged that there in the top part, that's in green. And often that rearrangement is just to follow into another question, or even to maybe show a proof. And often a question might say, hence, show this. And so that kind of thing might come up. Okay, here we have the reverse chain rule. So you've done the chain rule, which you can see at the first part, and we have to kind of reverse it. So let's just look at what we're doing here. We put our 7 out front, we subtract 1 from our exponent, and then the inside part, which is differentiated, and we get 2, so 2x plus 5. When we find a derivative, is 2. So we multiply by 2 as well, so 7 times 2 is 14. 2x plus 5 to the power of 6. So that's how we did the chain rule. So the reverse chain rule, which is a little bit awkward looking again as well, but you can see it there, 1 over 8 times n plus 1, and the exponent will change as well. So if you just kind of rewrite that there now, and just look at it in isolation. So we have a and n plus 1 on the bottoms there. So the 1, in a sense, is our 14, our constant. So we just leave that as it is. If you didn't have a constant there, then it would just be 1 over. So 2 times 6 plus 1, I put in 7. I'll change that now, actually. 6 plus 1 is 7, and then same for the constant down the bottom there. So you could say it's easy, you could say it's hard, it doesn't matter. It's just something that you have to practice, and it does look awkward, but once you get used to the idea and you can see it and you understand the how and the why, it becomes a lot easier. The example here, put the 12 out front, in front of our integral sign, our summation, and so we'll just rearrange that again with 2x minus 7 is to the power of a minus a half. Easier to look at, easier to calculate, especially at the beginning when you're doing these. And then 12 all over, 2 times the half, because plus 1, so minus a half plus 1 is a half. And then plus c, I'm going to simplify it actually first. Obviously put your plus c constant. We're doing definite integration, so just rearranging that to make it in the square root form. So 12 times root 2x minus 7 plus c is that answer for the reverse chain rule. So just looking back at that, and this is a little bit of a review lesson as opposed to a lesson. Just check that and make sure it makes sense. Just do 10 of them and you'll see. Exponential functions, straightforward enough. It's a special case where the derivative and indeed the integral are the same. So just be wary of the one little thing there where you have e to the ax plus b. It'll be 1 over a, and that's the only real difference. So you can see here we differentiated 6x minus 5 and got 6, so that's 1 over 6. Trig, cosine is sine is minus cosine. I think just sine is minus cosine. Just try and remember that one. And they are a little bit confusing for students sometimes when they have to just kind of, they're thinking of differentiation and you might actually write down the integral. That kind of thing has happened before. just have a look at them and just make sure they make sense. The example here has just got one of them in it. Most of these questions in your exam, we will come across, the product rule, the quotient rule. You will come across some algebraically difficult questions, but mostly it's a substitution. You're putting in the other one. So the integral of cosine is sine, and just be careful, of course, with the second ones on the right hand side. So 1 over a was 1 over 5 in this case, and when you're simplifying now, you'll get 2 over 5 sine to 5x minus 1 plus c. So do they get much harder than that? No, in a sense it's just a substitution of it, and just dealing with the skills that you've learned already with product rule, quotient rule, and chain rule, and so on. So we came across this already, where we had n cannot be equal to minus 1, and it's because of this natural logarithm. So the integral of anything like over x is going to be ln x, because a constant goes out front, and so we have 1 over x, which is ln x, so 5 ln x in this case plus c, and x has to be greater than 0 in both cases. So you'll see the second example, which is more expansive, 1 over a. So again, we put our 8 out front, so we can get our 1 over x form. So 8, and we'll have 1 times minus 4, isn't it? Yeah. ln 3 minus 4x plus c, and no space left. We just write it up the top. So minus 2 ln 3 minus 4x in brackets. You could also make it the validity of like x being greater than 0. You can check these things. Sometimes this question might come up as a little thing at the end, just to check it. So you have 3 minus 4x, which 3 minus 4x is greater than 0, so x is less than 3/4. Okay, that's your reverse chain rule. Then we did the exponential, and then we did natural logarithm just there. Here's a further definite integration question. It's a very common question. Differentiate something, and then when that form is given, you'll see some kind of comparison, or maybe something that's close to what we're given in the hence find solution. And we'll see that now in a second. So it involves differentiation and integration, and I think most of them have the reverse chain rule in there as well with this type of question. So just rearranging that. So 2x minus 1 to the power of a half is a half times 2x minus 1 to the minus a half, and times 2 as well, the inside part. So that's the chain rule. And we're using the product rule here. I haven't put that stuff in. I'm presuming you kind of know that already from what we've done already. So just remember to look over it if you need. And we'll rearrange that, put it under. So we have a negative fractional exponent. So put it under there. It's looking a little bit awkward now at the moment. We've just rearranged that to put the 3x squared first. I'm going to get the same denominator, so I have to multiply across. I'm going to have root 2x minus 1 on both denominators. Okay. And so I'm going to, if you think about this, just think of x to the power of a half times x to the power of a half is 1, is x to the power of 1. So that kind of idea might help you here with this. So you end up with 2x minus 1 on top there on your numerator on the right hand side. So from there we can multiply across 3x squared times 2x and 3x squared times minus 1, and we end up with something kind of close to what we have now in our integral above. So 7x to the power of 3 minus 3x squared. We're kind of missing a plus 5, which doesn't matter right now. It might look a little bit, might make you wary, but the whole point is that you see it so you can recognize that something has to be done. So we're going to separate it out. Now you know that 7x to the power of 3 minus 3x squared all over root 2x minus 1 is the integral of our y equals x cubed times root 2x minus 1. So we can replace that, because when we integrate it, we find that, if you see what I mean. So just looking at the next part. So I'm just circling them there. So just to see the comparison of what we mean there, differentiating and integrating. So we substitute it in because it's the same thing. And then we continue with our other part. So 5 goes out front, 2x minus 1 to the half, minus a half, dx, of course, is minus a half. And then we're simplifying from here, I think, except for that second part. So chain rule versus chain rule. Yeah, 5 times 2 times minus a half, 2x minus 1 to the half plus our c there then. So that's integrated out. And from there I can simplify, and also I think I can factorize as well. And 5 stays the same. And then I've put my x cubed plus 5 because I've the same thing in brackets. I have a root 2x minus 1 in brackets, so we can factorize that, as I said. So that's clear enough. So you can see the little techniques here, like you're going to use quotient rule, product rule, reverse chain rule, maybe just go back and forth of those, that kind of question there when you have further definite integration on your book or in your exam subscriptions, maybe things like that. So that was more or less like just introduction, just seeing how this stuff works for indefinite integration. And from then on you can move into more difficult questions, more complex forms. And after this, you'll do definite integration, which is actually a lot more palatable because you have graphs and you'll kind of see why this stuff exists.